I so weird starting the video with we're starting the video with I. Anyways, okay, let's try solving this question. Count square matrix with all ones. So I say let's try, right? I've solved it already, so I know the solution, but I'll still try and figure it out because I actually did enjoy this question. So let me draw the matrix and then I'll explain the question from there. But if you've read it, right, you understand the question. But if you don't understand the question, that's fine too. I'll explain again. Okay, so this is a matrix, right? This is a 4 by 3, right? Row by column. It's 3 by 4, right? Row by column. 3 by 4 matrix. Alright, so this is a 3 by 4 matrix. And the question says you should count the amount of squares, basically. And this is what they mean. This is a square, right? This is a square, right? This is a square. And this is a square. This is a 2 by 2 square, and this is a 3 by 3 square. You know what the square is, right? The square is basically have the same length and breadth, so 3 by 3 square, right? And yeah, so this is what makes the question a bit harder, right? So the question says you should count the amount of square. So if I'm to count the amount of square, I'll count this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can just say there are 10 1 by 1 square. 1 by 1 square. How about the 2 by 2 square? This is also a square. This is also a square, right? So this is a square 1, this is a square 2, this is also a square 3, and this is also a square 4. So there are four 2 by 2 squares. How about 3 by 3 square? Can we see it? Okay, so yes, this is just the 3 by 3 square. This giant 3 by 3 square. Okay, yeah, so there is 1 3 by 3 square. There is 1 3 by 3 square. Adding everything together, there are 15 squares in total. Which is 15. Yeah, 10, 1, 4, and 1. Okay, so now how do we actually calculate this programmatically, right? If we had a square that is maybe a 15 by 15 matrix, how do we calculate how many? Okay, so let's try to figure this out. Let's try to reason it, or let me just explain how I kind of reason about it. I know that every single one is a square on its own, right? So I can try counting all the ones I see. Right, 1, 1, 1, 1, 1, 0, 1, 1, 1. I can try counting all the ones I see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ones. Then I can now try counting the 2 by 2. So, but how do I know if how do I know if this is a 2 by 2, basically? How do I know that this is a 2 by 2? Well, I can know if this is a 2 by 2 by basically checking the neighbors, right? So let's say I want to do it downward like this. How can I know if this one is part of a 2 by 2? I can basically check. I can basically check down here, and down here. So first of all, I have to make sure this is a 1, right? Then I can check, is the left a right? Is this a 1 and is this a 1? If everything are 1, I know it's a 2 by 2. Okay, that's good. So what it means is this is in a 2 by 2 square, right? I can check this one too, right? If I check this one too, this, and this, right? This is also in a 2 by 2 square, right? How about this? Is this in a 2 by 2 square? This one is actually in a 2 by 2 square, right? If you think about it, this one is actually in a 2 by 2 square, but I need to have a perspective, right? Because if I don't have a perspective, I would say this is a 2 by 2. I'll take this as being 2 by 2, this as being 2 by 2, this as being 2 by 2. I'll basically take all these as being 2 by 2, which would increase the amount of squares I have, right? So what I want to do is what I think I might want to do is I want to know the edge of the square. So meaning that this is a 2 by 2, this being the edge of the square, right? This is a 2 by 2, this being the edge of the square, right? This is not a 2 by 2 because of that's not the edge, right? This is a 2 by 2, this being the edge of the square, and this is a 2 by 2, this being the edge of the square. And how do I know if they are all 2 by 2? By basically checking left, right, and across. Okay, which is all good, but how do I know if it is a 3 by 3, right? It becomes a bit more harder knowing if it's a 3 by 3, right? How do I know if this is a 3 by 3? If I check the left, I see 1, check the right, I see 1, check this, I see 1. I mean, I might have to check these two, and then I have to check. Okay, so I might have to go deeper. Check left twice. If this is 1, this one, check left, check right twice. If this one, then check middle. But how do I check this middle one? How do I check this one? So I might want to do something more sophisticated. Maybe do a right checking. Maybe having doing maths to calculate all the spaces. It's just very confusing, right? But looking at this too, I can actually kind of look at it in a dynamic programming kind of way. And when I say dynamic programming, all I just mean is that I kind of break this problem into a sub problem, and then build up from it, right? So meaning that I can solve part of the problem, and then by the time I include a new part of the problem, I can build up on my previous solution and go from there. Okay, so what I mean is, let's say I have this portion of the array, right? This is 1, 2, 3. Let's say I want to add this new portion of the array, right? How do I know that this is a square? Okay, so I want to take it from a different perspective. I want to take it, so I was taking it from this perspective and looking downwards, but I want to take it in the opposite perspective. So I want to take from this perspective, looking up, left and right? Since I'm taking my array in this portion and I'm adding it from this portion. So I can still do the same situation, right? And say, okay, this particular value, right? I want to look left, up and sideways. But now what I want to do is, instead of like looking at their value itself, I want to look at how many array or how many square did the value I'm looking at, how many square did they form? So basically what I'm trying to say is that this value, like this one here, it forms 1 square, which is this 1 square. This value, it forms 1 square. That's the maximum square it has to form. This form 1 square. This value here, this form 1 square. This value here, it's going to form 1 square, but looking at the neighbors, right? What is the maximum, what is the minimum value that each of these forms? This forms 1 square, 1 square, 1 square. Meaning that this will form 1 square and it would form a bigger square. Meaning that this actually forms 2 squares. Okay, so why this works is, I can think of a square as a combination of multiple squares, right? Basically, so a square of 2 by 2 is a combination of a 1 by 1, a 1 by 1, a 1 by 1, and a 1 by 1. A square of 3 by 3 is a combination of a a 1 by 1 here, right? Then a 2 by 2, right? Yeah, a 2 by 2 here, and a 2 by 2 here, basically. A 2 by 2 here, basically. So if you're at a point here, how do you know if this forms a 3 by 3 square? If you are going to form a 3 by 3 square, you want to know how many square this one forms, how many square this one forms, and how many square this one forms, basically. All right, so it might be a bit hard to end around, but I don't know, just try to stick with me and try to form that intuition, right? So what I'm going to do here is I'm going to jot this array twice, basically. So one, because I don't want to basically have to rearrange. I don't want to edit. I don't want to scatter this one. I want to use this one as a reference, but I'm going to scatter this one. Okay, so basically just the same thing. 1 1 1 and 1 0 1 1 and 1. Okay, so this is what I'm going to be doing. I'm going to be from here, right? What is the I'm going to look at the 3 branches, right? So what the question I'm going to be asking is how many square can I form from this place? If I look up, look left, look right, there's nothing there, so I can only form 0 square plus I can only form 0 square. If I'm at this point, how many square can I form, right? Look here, look here, look here. There's nothing. I can't form any extra square apart from where I am, so I can only form 1. Looking at this array, how many can I form? Yeah, nothing up, something here, nothing here, right? So I can only form 1. I can only form 1, which is the one that it's the square is. Look at this one. I can look here, and look here, right? There's nothing in all those directions, meaning I can only form 1. Looking at this one, I can look up, right, look left. There's nothing in this direction, meaning I can only form the 1, right? I'm looking at this, right? There's something in this direction, there's something in this direction, and there's something in this direction. But this is a 0. This is a 0, meaning that I can form 1 square here, I can form 1 square here, but there's a 0 square here, so this doesn't complete the criteria for me to have a 2 by 2 square, like another square, basically. So that means I can only form a 1 in this place, right? In this place, I can check here, and check here. If I check in the 3 direction, I can see that there's a 1 in each of it, meaning that since there's 1 in each of it, meaning that I can form another square, which including this particular square I have, right? So that means I can form this particular array, right? This particular block can form 2 squares. It's square and the square including everybody, right? At this point, right, how many square can I form? I can look here, and look here, right? If I look in these 3 directions, I can see that I can form 1 square. This give me a block of 1 square. This give me a block of 1 square. This will give me a block of 2 square, right? But since this give me a block of 2 square, I can only form the minimum, right? I can only form the minimum. I have a block of 2 square here. I have a block of 1 square here. I can have a block of 1 square here. This will give me a rectangle, not a square. So I can only get the minimum, meaning that I can only get 1. So meaning that I can only get 1, meaning that this would have to be 2. The block itself and the block which consists of this, and this. That's 2. Looking at this, I can look here, and look here, right? This will give me a block, this will give me a block, but this will not give me any block, meaning that this actually destroys my square, right? So that means I only have a 1 here. Looking at this, right, I can look here, and look here. This can only form 1 block. this can only form one complete square. This can form two complete squares, right? Are you this is are you this is where you are. This can only form one block. This can form one block. This can form two blocks. But this one block and this one block, they've already capped it, right? So I cannot actually utilize this one. I cannot actually utilize this block. So the maximum I can actually form is capped by this square, this blocks that can only form one square, right? Meaning that apart from this one, right, I can only form one more extra square, right? That means this is this is 2 basically. This is 2 basically. Now looking at this, right, this is 2 basically. Then looking at this, right, look here, and look here, right? This is 2, this is 2, this is 2. Meaning that this will form this, right, can form a square of 2, right? This 2 will form a square of 2 in this direction, and this 2 will form a square of this in this direction. This combination of these two will give me ability for me to form 2 squares, right? For me to form a square of 3 by 3 basically. This has given me 2 in this direction, 2 in this direction, 2 in this direction, and this one will just make it allow me to form a square of 3 by 3, meaning that this, right, this can form a square of 3 by 3, right? So at the end of the day, all we do is just add everything, meaning that this node will form only one square, this node will form one square, this one will form one square, this one will form one square, one square, this will form a 2 square, 2 square, 0 square, 1 square, 2 square, and 3 square. By the time we add everything together, we'll be having a 15 as the answer, right? So this is how basically how we solve it, right? Each node, right? So we're going to be updating the table basically. Each matrix cell would contain the maximum amount of block, the maximum amount of square we can form from it. The maximum amount of square we can form from it basically. All right. So from this demonstration, you can see that we're actually taking the minimum, right? So at this point, right, we have 2, 1, and 1. We took the minimum, which is 1, and added it, right? So at any point we are, so the algorithm basically is, right, at any point, would look at the top, look at the left, and we look at the diagonal. We take the minimum of it. So if the minimum is 1, we're taking the minimum because of we are having a cap basically. Something caps it off. The minimum caps it off, right? We're taking the minimum. So if the minimum is 1, that means we can only have that particular we can only have one extra square in addition to the square that we are adding, right? If the cap is 2, it means that we can have 2 more square with this with addition to the one we're adding. That's 3, right? So we take the minimum. Another thing we want to do is anywhere we have a 0, right, we don't need to check because of that 0 itself will cap it off. Basically 0 would make sure that it's not even possible for you to have a square at all. Yeah. So let's try to write it. So first of all, I'm going to calculate my row basically, matrix, and my column, and it's going to be matrix of the very first index. Yes. So after doing this, we can have our results, right, and start it at 0. So instead of building it and having to loop through it and adding again, what we can do is once we are done building the particular cell, would just add it to our results. Okay, so now we can loop. Let's loop in range of rows, and we are going to loop in range of columns. And what we are doing basically is we're going to see, you know what, first of all, if the matrix of that particular one, that particular column is equals to 0, let's just move to the next value. Let's just continue. Otherwise, what we want to do is we want to get the value in the left. So the value in the left will be, basically matrix of, we're going to the left, so we're on the same row, but we're going back to the column. We're going to make sure we only do this if going back to if this particular value is greater than or equals to 0. That's only when we can access the index, so we don't go out of range. If that doesn't happen, we just want to return 0 as L, basically. Right. We want to check the up part. The up part is we're doing basically the same thing, but instead of going to the left, we're going up, meaning we're going up a row, and at column C, and we want to do the same thing if r minus 1 is greater than or equals to 0, else you know that once we get 0, you know that our value, right, would be 0 is capping it off, right? So we're going to go up left, so will be matrix of going to the left and going up and going to the left, and we want to do this if r minus 1 is greater than or equals to 0 and c minus 1 is greater than or equals to 0, else is going to be 0. So the next thing we're going to do is we're going to take the minimum of everything, and we're basically capping it, right? And we're going to add it to whatever is, okay, I can say we're going to add it to whatever is in R plus C, right? But we know whatever is in R plus C is actually going to be 1, right? Because we already checked if this is 0. So let's just do this, right? Let's just do this, or better still, we can do this, so we don't really need to add it here. And what we'll be doing after that is we're going to be adding it to the result, basically. So result would be in addition to this, and then finally we're going to return our results, and we can test that. So we take the rows, we take the column, we're looping through it, right? And okay, so yeah, that works. You know what I would do? Let me print the matrix so that we can see how the matrix look like before we submit, right? So basically the matrix builds up, right? Anytime there's a 2, it means that particular cell can form 2 squares. Anytime there's a 3, that particular square can form 3 squares, basically. So we submit it, and we see that works very well. How about the time complexity? The time complexity is going to be basically O of n times m, basically the size of the array, because of we're looking through the size of the matrix. Basically we're looking through the matrix, right? And we're doing basically a O of 1 calculation on it. We're looking through the O matrix. We need to go through the O matrix, basically. Yeah, so that is how to solve this question. I hope I was able to explain it at this to some extent. Yeah. All right, anyhow, have a beautiful day. Yeah, bye.